Alright, here's one last demonstration of this setup I have going here before I install it into the machine. I have all the wires done, I have the mount made, I have everything done in the firmware. So basically what happens here is when this is plugged into the machine here and when any of these pins go low, it's going to trigger the smoothie through the connection here into the Smoothieboard. And when a pin is triggered through this button box module, or it's like the switch module, but it's more specific, it sends a G code throughout, echoes it across the -0 UART, which is one of the secondary UARTs, and sends a string of M701 N0 or whatever a corresponding feeder it goes to. So when that does that, it goes out into this Arduino and Bilsef's board here, the Schultz controller. But what I did is I cut the trace between the two MCUs here, and I wired in the UART directly into here so that I can bypass the USB and send the signals from the Smoothieboard over to here. So here's what happens. I'm gonna use my switch emulator here. I only use MacGyver brand switch emulators, with generics. You can get them, pretty much any office supply store. So here you go. You got the feeders, and when I trigger this pin here, it's going to advance it. And it also sends it there. Now second feeder, and then third feeder. Oh, well. So one thing that's interesting about these is that for some reason you have to send a message to the feeder before it actuates with the triggers. So I'm going to start that in a start G-code sequence or on boot G-code. But right now what I have to do is I have to send manually a trigger to open and close the shutter. And then once that's done once, then now they work. And as you can see, they work pretty fine. So depending on which pin I trigger here, 1, 2, 3, all the way up through 30, I have all of the feeders will trigger, and this basically will all run off itself. Has one 30-volt supply, which is powering Bilsef's board, and it's also going into the Smoothie, which also runs the 5-volt that's going over to the Arduino. And then this is inside the pick and place machine, and it's going to be plugged in there. In the future, probably by the next batch of boards, I'm going to integrate this board and this board all into one so that it eliminates this whole section, make it a lot cleaner. But as of right now, I've modified the pick and place. I designed a base plate and a mount and everything that holds all the feeders. So I can hold 30 more feeders here in the back, and as you can tell, it's right at the right height, because that little yellow part is actually a test point for the nozzles. So this is pretty much exactly the right height that needs to be at. It's very stable. This is, rock solid. I made this base plate out of 3/16" steel. I've also made it a lower plate so that there's actually in between, there's two things there. It's hard to kind of see here, but it'll make it so that when the feeder feeds out its tape in the back here, it's going to go down and underneath and come out the back here and into the waste. I have some printed parts designed too, but I didn't get them completed before I put this together, so that's not quite finished, but everything else is. And pick and place is now at the point of I'm going to throw all this in on the top, and this base here is magnetic, so I'm just going to stick it inside of here and hook up the necessary connections there. And then later on I'm going to put it right there in that empty spot, but it's a little big right now without refining the boards down. And since these are the ribbon cable outputs here, I can tap directly in instead of having to plug in up top. So it'll be a lot cleaner. But for now, that's as far as I got, and more to come.